Welcome back. One of the biggest advantages of NumPy is its collection of universal functions, or ufuncs. These are vectorized wrappers around C functions that allow you to apply mathematical operations to every single element in an array without using explicit Python loops. This lecture will demonstrate how to use common ufuncs for trigonometry, logarithms, and exponentiation. 1. Standard mathematical operations. Many standard math functions are available directly through NumPy. The benefit is that when you call np.sqrt on an array, it calculates the square root of every element simultaneously and returns a new array with the results. This is significantly faster than writing a list comprehension in Python to do the same task. 2. Trigonometric and logarithmic ufuncs. NumPy provides a complete set of trigonometric functions like np.sin, np.cosine, and np.tan. Similarly, for logarithms, np.log calculates the natural logarithm, and np.log10 calculates the base 10 logarithm. All these functions operate element-wise. For example, to plot a sine wave, you can generate a linespace array and directly calculate its sine values with one line of code. 3. Aggregation functions. Beyond element-wise operations, NumPy provides powerful aggregation functions. Functions like np.sum and np.min calculate a single scalar result from the entire array. Most aggregation functions are also available as methods directly on the array object, such as ar.mean, which is often the more convenient syntax. To summarize, ufuncs are the foundation of NumPy's speed. Our next lecture 35.05, Array Comparison. See you there.